Good day, everyone. For today is we'll tackle on solving linear recurrence relation. But first, we'll start in solving linear homogeneous recurrence relation with constant coefficients. So we will understand this theorem in layman's term. It states that a linear homogeneous recurrence relation with constant coefficients is a rule where each term in a sequence depends on previous term using fixed number. So here we have an is equals to c1 an minus 1 up to ck an minus k. So you can think of this as a recipe where each new term is made from mixing previous term with fixed amounts. And to solve this type of recurrence, so we should use an, we will replace it with rn. So this is not just a random solution. So it makes the equation more easier to handle. And then after we have used an or substituting the value of an to rn, so we have derived this type of equation wherein we replace every term with a power of k. So every an should be replaced with the power of r. And then after that is we will divide both sides by r raised to the power of n minus k. So this remove all the exponent involving n, leaving only powers of r. So after dividing is we will get this equation. So this new equation is then called the characteristic equation. So it is just a polynomial equation and the solutions rare are called the characteristic root. So we found that the sequence an equals to Rn is a solution of the recurrence if and only if R is a root of this characteristic equation. So we have here the theorem 1. So it states that suppose you have a recurrence relation of an c1 an minus 1 plus c2 an minus 2. So this means that each term, each term an is made by combining the previous term and the term before that. And then we use the weights na C1 and then C2. And then now the theorem says something important. So if the equation is squared minus C1R minus C2 is equals to 0 has two. So yaoy two distinct or different na roots. It says R1 and R2. Then the recurrence relation always produces sequences that looks like this. So kung may duha ka type of different na roots, where R1 and R2 came from the equation above called the characteristic equation. And then ang A1 and A2 are just constant that depend on the starting values or initial na conditions. So we have here an example. What is the solution of the recurrence relation? An is equals to an minus 1 plus 2an minus 2 with a0 is equals to 2 and a1 is equals to 7. So we will find the recurrence relation for this specific problem which has two different roots based on the theorem 1. So first is what we're gonna do is make the characteristic equation. So this an will be replaced by rn. So After replacing Rn is we derive into this solution or equation. And then after that is we will divide both sides by Rn minus 2. So after dividing both sides is we have derived into this equation. After that is we will combine the alike terms. So we have r squared minus r minus 2. So minus na siya because we have done the transposition na method. So we have r squared minus r minus 2 is equals to 0. After that is isolve nato ang ilaha quadratic na function or hanapon nato ang ilaha roots. So the roots of this r raised to the power of 2 minus r minus 2 is we have r minus 2 r plus 1. So this is the quadratic na equation. So therefore, based on this equation, we have seen that the roots are 2 and negative 1. And then we will write the general form of solutions. So as we have seen, based on the definition for the theorem 1, so we will have a two distinct roots. So this will be our equation. So an is equals to a1 rn over 1 plus a2 rn over 2. So here, again, ang ato a roots is we have 2 and negative 1. So what we're gonna do is we will replace the value of the roots based on the value nga ato nakuha using the geometry. So an is equals to a1 times 2 because again our r1 is equals to 2, 2n plus a2 times negative 1n. And then we will use the conditions or initial conditions to find the constant. As it was stated, the initial condition nga gihatag nila kay A0 is equals to 2 and our A1 is equals to 7. So we will plug n is equals to 0 and n is equals to 1. So n is equals to 0 and then our A0 is equals to 2. So we will use this equation. So we have here a1 times 2 and then ang value ng ato n is equals to 0. So 2 raised to the power of 0 plus a2 times negative 1 raised to the power of 0. So we have a1 plus a2 because any number raised to the power of 0 is equals to 1. Next is we will plug n is equals to 1. A1 is equals to 7. So we have A1 times 2 raised to the power of 1 because again our n is equals to 1 plus A2 times negative 1 raised to the power of 1. So kung ato ini sila ipang multiply na value, we can get 2A1 minus A2. Then after that is we will create the linear system which is a1 plus a2 is equals to 2 which is our a0 and then 2a1 minus a2 is equals to 7 which is our a1. So we will add the two equations para ma-eliminate na to ang a2 because as what we have seen, dili na to siya ma-add because they have different signs. So need gid na to siya i-subtract. So mawara ini siya ma-eliminate and then kung i-add na to ang alike terms, we have a1 plus 2a1, it results to 3a1 and then 2 plus 7 is equals to 9. And then both of these numbers are divisible by 3. So kung i-divide na to siya by 3, we have a1 is equals to 3. And then a2, so hanapon na to ang value sa a2. So is equals to 2, which is our A0. So 2 minus a value sa A1 is equals to 2. And then makita nato ang value sa ato A1 is equals to 3. So 2 minus 3 is equals to negative 1. So therefore, our A1 is equals to 3, and then our A2 is equals to negative 1. So we are in the final closed form, so we'll substitute the constant back. So an is equals to a1 times 2n plus a2 times 1 times negative 1 raised to the power of n. So we will substitute ang mga value sa a1 o sa a2. So therefore, the solution for these recurrence relations is we have an is equals to 3 times 2n minus negative 1 raised to the power of n. Next is we shall have the theorem 2. So this theorem deals with the current relations that looks like this. So this means na ang each term is made by combining the two previous na terms. So if you try to solve this kind of recurrence, you always start by forming its characteristic equation, wherein we always replace the value of an with r. So this is the characteristic equation. So usually, this type of equation has two roots or two solutions, like R1 and R2. But sometimes, both na roots are of the same nga number. So the same ra nga number ang ilaha roots. So this special case is what theorem 2 talks about. So the characteristic equation of r raised to the power of 2 minus C1r minus C2 is equals to 0 has only one root. So isa da R0. So this means nga ang two roots are equal or they are a repeated nga root. So when the root is repeated, the solution to the recurrence formula is this. So kung repeated ang root is amo ini siyaan gamiton na recurrence formula. So for example, what is the solution of the recurrence relation? An is equals to 6an minus 1 minus 9an minus 2 with initial conditions a0 minus 1 and a1 is equals to 6. So we will solve. First, again, is make the characteristic equation. So we will replace an with rn. So this was the given equation. So we'll replace an with r. So after replacing, we have derived with this equation. And then next is we will divide both sides by rn minus 2. So after ma-divide is we have derived into this solution since we have combined like terms. Okay, ang result na niyon kay R2 is equals to 6R minus 9. So, i-derive din nato siya into combining like terms equals to 0. And then, kung makita nato, kung we will solve this in the quadratic niya na function, so, there is only one root. However, ma-negative siya because it is a repeated na root. So, r minus 3 raised to the power of 2. So, it is a repeated nga root. So, the only root nga to makita is 3. So, based on the definition nga gihatag sa theorem 2, is yaoy iya dagayod only one root. So isa da ang root niya. So on this example, makita nato nga there is only one root which is equals to 3. So the general solution for the repeated na root is we have an is equals to a1 plus a2n times 3n. So 3 tungod kay amo sa inian iyaha root. So, or equivalently, ato siya i-multiply. So, we have an is equals to a1 times 3n. Okay, ato i-multiply. And then we have a2n times 3n. So, we will plug the initial conditions to find a1 and a2 para mahanap nato. So, we will plug n is equals to 0 and n is equals to 1. And then makita na to ang gihatag nila ng mga initial conditions are a0 is equals to 1 and then ang a1 is equals to 6. So, n is equals to 0 and then our a0 is equals to 1. So, a1 plus a2 times 0. So, ang formula sabtuod nato gigamit nganhi is this formula which is the general solution for repeated root. So we have a1 plus a2 times 0 because again our n is equals to 0. 3 raised to the power of 0. We have a1 times 1 because again any number raised to the power of 0 is equals to 1. And then ang a2 times 0, so 0 sa gayud siya. So we have a1 is equals to 1. And the next is we have our n is equals to 1 and then our a1 is equals to 6. So a1 plus a2 times 1 tungod kay nga to n is equals to 1 times 3 raised to the power of 1 is equals to a1 plus a2 times 3. And then we have 6 because this is the value of our a1. So 6 is equals to a1 plus a2 times 3. And then 6 is equals to a1. So the value of our a1 here. So we have 1 plus a2 times 3. And then both of these number is divisible by 3. So 6 divided by 3 is we have 2 is equals to 1 plus a2. And then the next thing that we gonna do is to combine alike terms. So we have a2 is equals to 2 minus 1. So therefore, with our a1 is equals to 1, we get a2 is equals to 1. And then we will write the final solution. So again, the general solution for the repeated root is this one. So we have our an is equals to 1 plus n times 3 raised to the power of n. So kung ato yaon siya i-multiply is we will get an is equals to 3n plus n times 3 raised to the power of n. Because ang value ng ato a2 is equals to 1, makita nato. So kung i-multiply na nato ang 1 times n, we would only get n. So this has been the shortcut na method. So again, this would be the recurrence relation for the theorem 2 na example with one and only nga root. Isa daan iyaha root. And the next is we have the theorem 3. So we are studying recurrence relation of the form an c1 an minus 1 up to ck an minus k. So this is a linear homogeneous recurrence relation with constant na coefficients. So this theorem tells us what the general formula or the closed form for the sequence looks like. So this theorem says if you know the roots of the characteristic equation, then you already know the shape of the solution. So meaning, you turn the recurrence into a polynomial or characteristic equation, and then you will find its root, and then the solution is always a combination of those roots. So we have here an example of theorem 3. So it states that we will find the solution to the recurrence relation an is equals to 6an minus 1 minus 11an minus 2 plus 6an minus 3 with the initial conditions of a0, a1 is equals to 5, and a2 is equals to 15. So again, first that we're gonna do is to create a characteristic equation. We will replace or substitute an is equals to rn. So based on this given example, i-replace na to ang value ng an with rn. So therefore, we have rn is equals to 6rn minus 1 minus 11rn minus 2 plus 6rn minus 3. And then out of this equation is we will divide both sides by rn minus 3. Tungod kay there are 3 nga terms. So rn, i-divide na to ini siya ng mga terms by rn minus 3. So after na to i-divide ang both sides by rn minus 3, so amo ini ang ato makuha na equation. So after i-divide both sides by rn minus 3, so we will solve the quadratic equations of this equation. So makita nato that we have r minus 1 times r minus 2 times r minus 3. So the roots are 1, 2, and 3 because they are 3 distinct roots or lahi-lahi ang values sa roots. Unlike sa theorem 2 na there is only one root, nganhi sa theorem 3 is lahi-lahi ang 3 nga roots. So the general solution is a linear combination of 1n, 2n, and 3n. So an is equals to a1 times 1n plus a2 times 2n plus a3 times 3n is equals to a1 plus a2 2n plus a3 times 3n, where ang a1, a2, and a3 are constant nga determined by the initial na mga conditions. So we will use the initial conditions. So first is i-plug in nato ang n values na 0, 1, 2 into the general form. And then based on the given nga problem, the initial na mga conditions, we have a0 which is 2, a1 is equals to 5, and then a2 is equals to 15. So we have here our a1 plus a2 plus a3, which is the value of our a0, and then a1, which is equals to 5, is equals to a1 plus 2a2 plus 3a3. And then we have our a2, which is equals to 15, and our n is equals to 2. So a1 plus 4a2 plus 9a3. So by using the linear na systems, ang mga equations, we have a1 plus a2 plus a3 is equals to 2, and then a1 plus 2a2 plus 3a3 is equals to 5, and then a1 plus 4a2 plus 9a3 is equals to 15. So we have 3 equations. So next is we will solve the system using a simple subtraction nga method. So our goal is to eliminate a1, so we can focus only on a2 and a3. So we eliminate by subtracting subtracting the equations. So, first is isubtract nato ang equation 1 from equation 2. So, makita na to nganhin that there are common nga terms which is A1. So, mawara na ini and then subtracting 2A2 minus A2, we have A2 plus 3A3 minus A3, we have 2A3 and then 5 minus 2, we have 3. So, this would become our equation A. And the next is we will subtract equation 2 from 3. So our equation 3 is we have A1 plus 4A2 plus 9A3 is equals to 15. And our equation 2 is A1 plus 2A2 plus 3A3 is equals to 5. So again, mawara ini because if i-subtract na to ang alike term, so mawara siya. And then 4A2 minus 2A2, we have 2A2. And then 9A3 minus 3A3, we have 6A3. So 2A2 plus 6A3 is equals to 10. Tungod kay 15 minus 5, we have 10. And then, so, makita nato na there are values that can be divisible by 2. We have 2, 6, and 10. So, divisible by 2 siya. So, we have A2 plus 3A3 is equals to 5 after dividing the values by 2. So, this would become our equation B. And the next is, isubtract nato ang equation A from B. So, ang ato equation B, we have A2 plus 3A3 is equals to 5 minus A2 plus 2A3 is equals to 3. So, makita na to na there are alike terms. So, ato ini siya paptanggalon. And then, 3A3 minus 2A3. So, ang mabilindakan nga 1A3. However, ang pagka-state na nanyaon is A3. And then, 5 minus 3, we have 2. So, therefore, ang value sa ato A3 is equals to 2. And then after that, since nakuha na nato ang value sa to A3, so we will plug A3 is equals to 2 back into equation A. So i-substitute nato. So we have A2 plus 2A3 is equals to 3. So A2 plus 2 times 2 because this is the value of our A3 is equals to 3. And then A2 plus 4 is equals to 3. And then i-combine na to ang alike terms. So, matranspose ini siya. It would become A2 is equals to 3 minus 4. So, it would become A2 is equals to negative 1. And then, we will find, nakita na sa nato ang ato A3 o ang A2, ang values nila. So, we will find A1 using equation 1. So, ini na equation. So, hanapon na to ang ato A1 using this equation. So, A1 plus A2 is equals to A3 is equals to 2. So, i-substitute na nato ang values sa A2 o A3. So, we have A1 plus negative 1 since this is the value of our A2 plus 2 is equals to 2. So, we have A1, negative 1 plus 2. So, minus sa siya and then ang bigger nga number amoy kopyahon ang sign. So, we have A1 plus 1 is equals to 2. And then A1 is equals to 1. Tungod kay again, combine like terms. So, we have 2. Matranspose ini siya nganhi. We have 2 minus 1. So, we have A1 is equals to 1. So therefore, we have our A1 is equals to 1 A2 is equals to -1, and then our A3 is equals to 2. So we will write the final solution, which is an. So again, ang value sa to A1 is 1, and then the A2 is equals to 2n, plus ang value sa A3 is we have 2 times 3n. So therefore, this is the recurrence relation of the theorem 3 example. Next, next is the theorem 4. So we want to solve a recurrence relation like this. So this theorem tells us what all possible solution looks like depending sa roots of the characteristic equation. So again, ang first gid nato nabuhaton is we will have to form the characteristic na equation wherein we will replace the value of an is equals to rn, and then take the recurrence relation and create its characteristic equation. So we would derive into this equation, which is just a polynomial equation whose root determine the pattern of the solution. And then we will compute the roots, which are the R1, R2 up to RT. So some roots may repeat. So if a root repeats, we say it has multiplicity. And then each root produces part of the solution. So if the root does not repeat, it contributes a simple term, again, which is ar raised to the power of n. So example, we will find the solution of the recurrence relation an is equals to -3an minus 1 minus 3an minus 2 minus an minus 3. And then ang initial na conditions are a0 is equals to 1, and then a1 is equals to -2, and then a1 is equals to -1. So again, ang first grid na to nabuhaton is we will replace an with rn. So in enough equation, pulihan na to siya ng rn. So after pulihan, we have derived into this equation, which is rn is equals to -3rn minus 1 minus 3rn n minus 2 minus rn minus 3. And then after that is i-divide na to both sides by rn minus 3 ang inina equation. So after dividing is ang makuha nato na value is we have r3 minus 3r2 minus 3r minus 1. So again, i-combine nato ang mga terms. So we have r3 plus 3r2 plus 3r plus 1 is equals to 0. So, kung matingala ka mo na nga R3 daang nabilin because kung i-divide nimo ang mga values is may cancellations na mahitabo. Same ani Rn. So, mawara ini siya. So, makita na to na ang mabilinda is 3. So, that is why it has R3. So, same as sa iban na mga equations. So, if we will solve the quadratic equation of this, so ang makuha nato is r plus 1 raised to the power of 3. So the characteristic equation has a single root of r is equals to -1 with multiplicity 3. So ikatulo nato siya gi-multiply because it is cube. So kay ikatulo sa siya, so that is why our r is equals to -1. And then the general form of the solution, so for multiplicity 3, ang general solution gadyo niya is an is equals to a0 plus a1n plus a2n squared times -1 raised to the power of n. where is A0, A1, and A2 are constant. We need to find using the initial na mga conditions. So, we will use the initial conditions nga gipanghatag to find the constant. So, our A0 is equals to 1, and then our A1 is equals to negative 2, and then ang A2 is equals to negative 1. So, these are our initial na mga conditions. And then, our n is equals to 0. So, A0 is equals to A0 plus A1 times 0 since our n is equals to 0. And by the way, again, ang ato gigamit na solution is for the multiplicity 3. So, kung ikatulo nimo i-multiply ang roots. And then, a2 times 0 raised to the power of 2. And then, times negative 1 raised to the power of 0. So, we have a0, tungod kay a1 times 0 is 0, a2 times 0 is 0, and then 1, negative 1 raised to the power of 0 is always equals to 1. Again, any value raised to the power of 0 is equals to 1. So, that is why we have a0 is equals to 1. And then next is for n is equals to 1, so we have our a1 is equals to a0 plus a1 times 1. Tungod again, our n, here we have our n is equals to 1, and then a2 times 1 raised to the power of 2 is equals to negative 1 raised to the power of 1. So, we have, so kung i-multiply nimo ini siya is amo na gihapon ang constant na value an mo gawas. We have a1 and a2 tungod kay 1 na sa siya. So we have negative a0 plus a1 plus a2 is equals to negative 2. And then a0 plus a1 tungod kay i-divide nimo siya both sides. So, we have a0 plus a1 plus a2 is equals to 2. Kaya they have values. Kung imo siya i-multiply, we have 1. 1 plus 1, we have 2. So, for n is equals to 2, we have a2 is equals to a0 plus a1, and then our n now is equals to 2. And then a2 times 4, tungod kay 2 raised to the power of 2. So, 4 siya. And then times negative 1 raised to the power of 2. We have a0 plus 2a1 plus 4a1 is equals to negative 1. So, we will solve the system of equations. So, makita na nato anhi that the value of our a0 is equals to 1. So, mayon siya ang a1 na nato. We have the first equation. So, we have a0 is equals to 1. And then, next is a0 plus a1 plus a2. So, amo ini na equation na sa bato gamiton. So, we have the value of a0, which is 1, plus a1 plus a2 is equals to 2. And then a1 plus a2 is equals to 2 minus 1. Tungod kay again, we will combine the same nga term. So, a1 plus a2 is equals to 1. And then the third equation, we have, so ini ato gamiton. So we have a0 plus 2a1 plus 4a2 is equals to negative 1. Again, the value of a0 is equals to 1 plus 2a1 plus 4a2 is equals to negative 1. So 2a1 plus 4a2. So we will combine like term, matranspose ini nga din, we have negative 1. So negative 1 times minus 1, we have negative 2. So Anilisab na mga values as what we can see. So this theorem fills with recurrence relations that looks like this. So this means na ang each term is made by combining the two previous na terms. So if you try to solve this kind of recurrence, you always start by forming its characteristic equation, wherein we always replace the value of an with r. So this is the characteristic equation. So usually this type of equation has two roots or two solutions like R1 and R2. But sometimes both na roots are of the same nga number. So the same ra nga number ang ilaha roots. So this special case is what theorem 2 talks about. So the characteristic equation of r raised to the power of 2 minus c1r minus c2 is equals to 0 has only one root. So isa da r0. So this means nga ang two roots are equal or they are a repeated na root. So when the root is repeated, the solution to the recurrence formula is this. So kung repeated ang root is amo ini siya ang gamiton na recurrence formula. So for example, what is the solution of the recurrence relation? An is equals to 6an minus 1 minus 9an minus 2 with initial conditions a0 minus 1 and a1 is equals to 6. So we will solve. First, again, is make the characteristic equation. So we will replace an with rn. So this was the given equation. So we'll replace an with r. So after replacing, we have derived with this equation. And then next is we will divide both sides by rn minus 2. So after ma-divide is we have derived into this solution since we have combined like terms. Okay, ang result na niyon kay R2 is equals to 6R minus 9. So, i-derive din nato siya into combining like terms equals to 0. And then, kung makita nato, kung we will solve this in the quadratic niya na function, so, there is only one root. However, ma-negative siya because it is a repeated nga root. So, r minus 3 raised to the power of 2. So, it is a repeated nga root. So, the only root nga to makita is 3. So, based on the definition nga gihatag sa theorem 2, is yaoy iya dagayod only one root. So, isa da ang root niya. So, on this example, makita nato nga there is only one root which is equals to 3. So, the general solution for the repeated nga root is we have an is equals to a1 plus a2n times 3n. So, 3 tungod kay amo sa inian iyaha root. So, or equivalently, ato siya i-multiply. So, we have an is equals to a1 times 3n. Okay, ato i-multiply. And then, we have a2n times 3n. So, we will plug the initial conditions to find A1 and A2 para mahanap nato. So, we will plug n is equals to 0 and n is equals to 1. And then makita nato ang gihatag nila ng mga initial conditions are A0 is equals to 1 and then ang A1 is equals to 6. So, and it's the same sila and divisible by a value of 2. So, kung i-divide mo siya ng by 2, so ang result na niya is A1, and then we have 2A2 is equals to negative 1. Kaya ani divisible by 2 sa sub siya, so negative 1. So, we will solve for A1 and A2. So, base sa ito nakuha na value is, amo ini siya, and then this one. So, we will subtract the first from the second na equation. So, A1 plus 2A2 minus A1 plus A2. So, ang ilang mga values, we have negative 1 minus 1. So, the value of our A2 is equals to negative 2. Tungod kay again, makancel ini siya, cancel. So, we have 2A2. So, i-divide nimo siya. So, ang ma-result niya is negative 2. And then A1 plus negative 2 is equals to 1. So, therefore, ang ato A1 now is equals to 3. Tungod kay again, ini na value ang ato gamiton para mahanap na to ang ato A1. We have A1 plus the value of our A2, which is negative 2. And then, i-transpose ini mo siya, i-plus 3. So, the value, plus 2. So, the value now of our A1 is equals to 3. So, therefore, our values for A0 is equals to 1, and then A1 is equals to 3, and then A2 is equals to negative 2. So, by using the general equation for the theorem 4 is we have AN is equals to A0 plus A1N plus A2N squared times negative 1N. So, i-replace dayon nimo ang mga values for A0, A1, and A2. So, this would be the final nga recurrent solution for the given nga example. So, now is we will tackle on the linear non-homogeneous recurrent relations with constant na coefficients. So we already know how to solve homogeneous recurrent relations, those that look like this. So this one. Now we want to handle recurrent relations that are non-homogeneous. So a recurrent relation becomes non-homogeneous when there is an extra term that does not involve previous na mga term. So we have here an example which is an is equals to 3an minus 1 plus 2n, wherein ang 3an minus 1 kay nagdepend siya sa previous na term, and then this 2n is only an extra term depending only on n. So, this what makes it non-homogeneous. So, the general form, this one, the coefficients C1, C2, and CK, so ini sila C1, si C2, ug si CK, are constant. And then, ang term nga Fn, nagdepends only on n, not on any earlier na mga a's. So, the key idea of this theorem states that to solve a non-homogeneous nga recurrent relations, you need to break the problem into two parts. So, first is isolve na to ang isolve ang homogeneous na part, and then find one particular solution of the whole equation, and then we will add them together. So we have here the theorem 5. So suppose you have a recurrent relations that look like this. So this formula has two parts. So a part that depends on previous na terms are this one, ini sila. And then the extra part, which is the f of n, this makes the recurrence non-homogeneous. So if you can find one particular solution, so this one, to the whole equation, meaning one sequence that satisfied the full formula, including Fn, then every possible solution to the recurrence is just. So, where ang AP of n is a particular solution to the full recurrence, and then ang AHN is a solution of the non-homogeneous nga recurrence. Ini siya, which is this one. Ini ta siya. Or ilabot yon Fn. So, this is the same recurrence but without f of n. So we have here an example that we need to find the solution for the recurrence relations an is equals to 3an minus 1 plus 2n. What is the solution with the initial condition of a1 is equals to 3? So, we will solve the associated homogeneous recurrence by dropping the 2n and solve. So, with this solution, so i-drop na to ang 2n. So, ang unang-unahin na to pag-solve is ining 3an minus 1. So, ang ato gamiton na formula is we will use AHN is equals to 3AHN minus 1, and then AHN is equals to A times 3N for some constant A. So, constant yon an A. Diyaon siya maotro. And then, we will find the particular solution for the non-homogeneous na part. So, ini, hanapan na sab nato siya ng equation or formula. So, the non-homogeneous term is Fn is equals to 2n, a polynomial degree 1. So, we will try a polynomial of the same degree. Apn is equals to Cn plus D. So, amo gyud yaon siya an formula, where C and D are constant to solve for. So we will substitute into the recurrence Cn plus D is equals to 3. So we will have the 3, na to C, 3 times C, and then our N is equals to 1. So we have 3 times C times N minus 1 plus D plus our 2N, which is our Fn. So if we will multiply this, we will get an equation which is 3Cn, and then we have 3C, and then we will have 3D plus our 2N. So we will find a particular solution for the non-homogeneous na part. So we will bring left minus right to 0 and collect ang mga like terms. Ken, ang mga nay the same na mga terms kay ato sila ipang combine. So we have 3C minus C because makita na to based on the previous na gihatag na equation ini siya. So i-combine na to ang mga the same nga mga terms. So we have 3C minus C plus 2 times N, gigawas na to ang N, plus 3D minus 3C minus D. So, ang ma-equals niya, 3C minus C, we have 2C plus 2, igawas ang N, plus we have 3D minus D, we have 2D minus 3C. So, for this identity to hold for every n, the coefficients must be 0. So, ini sila. So, we have 2C plus 2 is equals to 0. So, C is equals to negative 1. Tungod kay i-divide na to siya by 2. So, we have negative 1. So, ang inisab sila na value, ato siya kuhaan ng identity. So, we have 2D minus 3C is equals to 0. And then, ang value ng C nga di is ato siya is-substitute. We have 2D minus 3 times negative 1 is equals to 0. So, we have 2D negative 3 times negative 1. So, ma-positive 3 siya is equals to 0. And then, i-divide na to siya by 2 para makuha na to ang value ng D. So, pag-divide na to, ang result is equals to negative 3 over 2. So, therefore, our AP of n is equals to negative n minus 3 over 2. So, for the general solution, we will add the homogeneous plus the particular. So again, we have our a times 3n ini for our homogeneous. We have a times 3n minus our particular, which is negative n minus 3 over 2. So we have a times 3n minus n minus 3 over 2. And then, we will use the initial condition nga gihatag, which is a1 is equals to 3 para mahanap nato ang a. So, we will plug n is equals to 1. So, 3, again, because this is our a1 is equals to a times 3 raised to the power of 1 because our n is equals to 1. So, ang ato gamiton na equation again is this one. So, we have minus 1 because our n is 1 minus 3 over 2. So, we will compute this equation. I-compute na to. So, ang result niya is negative 5 over 2. So, 3 is equals to negative 5 over 2 plus 3a. So, is equals to 3a is equals to, kung i-multiply mo ini siya, we have 3 plus 5. I mean ini. So, i-multiply na to siya. So, we have 3 plus 5 over 2. So, times, and then we will add. So, 3 times 2, 6 plus 5, we have 11 over 2. So, therefore, a is equals to 11 over 6. So, the final answer is we will have an is equals to negative n minus 3 over 2 plus 11 over 6 times 3n.